What are Pythagorean triples and their divisibility rules? Have you ever wondered how certain sets of numbers can form right triangles? Today, we will uncover the fascinating world of Pythagorean triples and their divisibility rules. Pythagorean triples are groups of three positive integers that follow a special relationship defined by the Pythagorean theorem. This theorem states that in a right triangle, the square of the length of the longest side, known as the hypotenuse, is equal to the sum of the squares of the other two sides. In mathematical terms, if we label the sides as a, b, and c, the equation is a squared plus b squared equals c squared. A classic example of a Pythagorean triple is the set of numbers 3, 4, and 5. If we square these numbers, we find that 3 squared plus 4 squared equals 9 plus 16, which equals 25. And guess what? 25 is also 5 squared. These triples are particularly useful in geometry because they provide integer side lengths for right triangles. If you take any Pythagorean triple and multiply each number by the same positive integer, you create a new Pythagorean triple. For instance, if we multiply 3, 4, and 5 by 2, we get 6, 8, and 10, which also satisfies the Pythagorean theorem. Now let's talk about primitive Pythagorean triples. These are special sets where the three numbers do not share any common divisor other than 1. For example, the set 3, 4, and 5 is a primitive triple. However, the set 6, 8, and 10 is not primitive because all the numbers can be divided by 2. When it comes to divisibility rules for Pythagorean triples, there are some interesting points to note. In any primitive Pythagorean triple, one of the legs, which are the shorter sides, is even while the other leg is odd. The hypotenuse is always odd. This pattern helps ensure that the triple remains primitive. Additionally, in primitive triples, the two legs are coprime, meaning they do not share any common divisor. Their greatest common divisor is 1. When you multiply a primitive triple by any positive integer, you create a non-primitive triple where all three numbers share that integer as a divisor. These divisibility rules are essential for identifying whether a triple is primitive or a scaled version of another triple. They also play a significant role in understanding the properties of right triangles with integer sides. So, Pythagorean triples are not just random sets of numbers. They are structured groups that fit perfectly within the framework of the Pythagorean theorem. Their divisibility rules help us distinguish between primitive triples and their multiples, providing a clearer picture of the relationships between the sides of right triangles.